answer your question, we're going to be in radian mode. I'm going to quick turn my plots off though before I forget. Alright, so I'm going to type in 3 divided by cosine of theta. I'm going to make sure that I'm in radian mode, which I am. And now theta, guys, theta is going around that polar paper, okay? So what's the minimum window that I want to do for theta then, if you think about it? But in terms of pi, 2 pi, right? Okay, so the minimum I want to do is 0 to 2 pi, because that would give me one full rotation around that polar paper. For x min and x max, I'm going to just go -5 to 5, because I need to just see the line at x equals 3. So that will give me enough for that. And the y min and y max -5 to 5. And there we go. Pretty nifty. Did you get it to show up?
Wait,
good.
What did you put for the r equals 8? You just put 3. Oh, 3.
Okay. So, if I asked you to graph 3x plus 4y equals -2, what kind of line is this? It is a line. It's not horizontal or vertical, right? Just on an angle. We call those oblique lines. Okay, an oblique line means at an angle. And I could do that by changing the slope-intercept form. So it's going to either, well, let's see here. I think it's going to have a negative slope, actually, so it's going to be going down like this. We're going to convert this to a polar equation. So before I took out the x and replaced it with r cosine theta, here I have an x and a y. What do you think you'd do here? I'm going to take x and replace it with r cosine theta, and y and replace it with r sine theta. So here we go. So we're going to take out the x, and we're going to write r cosine theta. We're going to take out the y and write r sine theta. Okay, so remember our goal is to solve for r. So what I'm going to do is I'm going to pull out that common factor of r to the front. And then I have 3 cosine theta plus 4 sine theta equals -2. And then last, to solve for r, I'm going to divide by that whole parentheses. And I should get an oblique line when I do that. Make sure that you use parentheses on the denominator. Okay. Now notice this kind of the same thing happens in polar mode, or can happen, that happened in with parametric mode. Because we're controlling what r is, then we get this line that stopped. If I wanted to get this part to show up, I think I would make it like something like -2 pi, because it looks like it started there and then went the other way. Alright, you with me so far? Alright, so back to geometry. Can anybody tell me what this is? It is a circle. So when you have x squared plus y squared equals r squared, that's a circle centered at 0, 0. When it's x minus 3 squared, that just moves it over 3 units to the right. Okay. But the issue here is that I want an r again. And so what I'm going to do is I'm going to expand this so I can get an x squared plus y squared and replace it with an r squared. Okay. so x minus 3 squared really means this. Let's not forget that. Doesn't mean x squared minus 9. So x minus 3 squared is x squared minus 6x plus 9 plus y squared equals 9. So I'm going to rearrange this. Are you all good? I just rearranged the order. And also, what happens when you subtract 9 from both sides? Is equal to 0. Okay. So we kind of have two things going on here. I have this x squared plus y squared, which the reason why I put them together is that x squared plus y squared I can swap out for an r squared. And then I have this x. So what I'm going to do next is I'm going to take out the x squared plus y squared, and I'm going to replace it with an r squared. And then I'm going to take out the x and replace x with an r cosine theta. So then what I'm going to do is I'm going to do you understand what I just did? Well, you can, which would give you something that is definitely polar, okay? If I want to put in my calculator, though, do you see how taking the square root would still have an r in here, and I can't put an r into my calculator? So you can do that. I'm going to do this a second. Do you see how if I divide it out, okay, then I would just get r equals 6 cosine theta. Alright, so we're going to try then putting that in our calculator and confirming that we're going to get a line for that. Well, it probably doesn't look like a circle because it's not, it looks like an oval. Yeah, because we're on a rectangle screen, and so everything's squished. It's like I tell people, remember, if you don't have your settings right on your HD TV, have you ever seen that?
Yeah.
And people look like really short and fat, right? It's the same thing with the circle. If you put a circle on that screen, yeah. But it's all right. Let's look. And the radius, it should be moved 3 units to the right, and it is. Yeah, it does look like an oval. But if you actually count it up, this does go up to 3 there and so on. All right, cool. So that's going, these were all function mode going to polar mode. Let's go backwards. Okay. So I wrote here our goal because there's really, we need to try to have a strategy here because sometimes it's like there's not going to be something you need. Remember from the previous page that if I had an r squared, I could swap it out, okay? Or if I had an r cosine or an r sine. So sometimes I might have to multiply like both sides by something to get one of those things. So let's take a look. That's our goal. We need to get an r squared, an r cos, or an r sine, because then we can swap those things out for either x squared plus y squared, x or y. So the first one, let's at least first rewrite it as cosine. You might notice something familiar about this. All right. Would you agree that this is 3 divided by cosine theta? Okay. Remember, our goal is to get an r squared or an r cos or an r sine. What could I do to both sides? If I multiplied both sides by cosine of theta, what that would do is get rid of the cosine theta there, and that would give me an r cosine theta. That's one of the things I want. From the previous page, what can I replace r cosine theta with? X. Okay, so isn't this the reverse of example 1 that we did? Okay, this is just a vertical line. Alright, so we should also do something that's, we've studied lots of different functions so far, so there's lots of different examples I could do, but let's do one like this, where at first it looks the same, but it's actually different because the cosecant is on the same side as it. So this is the same as r over sine of theta, right, equals 4. So I try doing the same thing, where I multiply both sides through by sine. Seems logical, right? Okay, but I have an r over here and a sine over here. That's not the same as r sine theta together. Similar, you said do we square it? Because then that would give me an r squared, but then I still would have a sine squared. I can't replace sine squared with anything. It will be. How else could I get an r squared? By multiplying both sides by r.
Oh my, yes.
Okay, so I'm going to multiply both sides by r. And then I have r squared here, which you're right, you're going to be able to replace. And then that also gives me what I want here, 4r sine theta. Okay. So I'm going to take that out, and I'm going to take this out. And anytime you see this x squared plus y squared, what we should in our heads know is this is going to be a circle, because it's got an x squared plus y squared in it. And what are we going to replace r sine with? Y. Okay, now I'm going to stop you right here. First of all, if you get to here, have you gotten it to function mode? Yes. But what we're going to do next is we're going to put it into the form of a circle. Okay, and so we're going to review some things from algebra to do that. If we wanted to have a circle, we would have x, or x minus h squared, plus y, or y minus k squared, equals radius squared. I'll write that up here. That's the general formula for a circle. So here's what I'm going to do. I'm going to put the y with the y, and then I'm going to complete the square to get it in factored form, and see if I get a radius to show up. I'm going to leave some space here. Would you leave some space here? Okay. There is no x term, so there's nothing. That means that h is just 0. Okay. So this is x coordinate is centered at 0. There is a y term, so my goal is to write it in factored form. So we're going to complete the square to do that. Do you remember how to do completing the square? You got to pick something to put here that's going to make it y minus something squared. We take half of this term, -2, and we square it, which is 4. And that's always the case. For completing the square, you take half of the middle term and you square it. I just added 4 to this side, so now what do I need to do? Add 4 to the other side. Now we're going to get our radius to show up. Alright, now let's factor it. Again, x squared is just x squared. In factored form, how would I write this? Y minus 2 parentheses squared. Y minus 2 times y minus 2, or y minus 2 squared. And now it's the form of a circle. Okay, so this is a circle if I were describing. The center is 0, 2. And remember, this is radius squared, so what's the radius? And a radius of 2.